Hi, Year 11. It's Mr. Burridge. I've got a little bit to go over for the Paper 1 exam on Wednesday. Um, I hope your revision's been going well. I am going to really be talking to you about something which isn't just Paper 1 specific, it's the equations, that's specific, but then the units and conversions is relevant to everything that you will do, potentially a little bit in chemistry and in biology as well, mainly in the physics one though. First things first is your equations, right? Now, what I've done here is I've looked at all the equations that you'll be given, and obviously you're given every single one of them, but I've just filtered them down to the paper one equations, and I've sort of color coded them into which topic it could be talking about, or whether they could be used. That's not super important because it's like it doesn't matter which topic it is, but it can give you maybe a little bit of insight, right? We can see that energy and electricity have a lot of equations. Efficiency is something which comes up for both of them, and that could suggest that efficiency would be more likely to be asked, but there's no real weighting to any of these. You will be asked about every single topic, right? Particle model doesn't have a lot, but again, you are going to be asked about some of them, and there will be some sort of calculation questions in there. Atomic structure is your only paper one topic that doesn't actually have an equation for it, but there is still the half-life calculations. And remember, the half-life, the definition for it is the time it takes for the mass or the activity or the number of radioactive nuclei to halve. So for that, you're always dealing in halves or multiples of 2 if you're going back through time. Okay, that's not actually an equation, but that definition you still do need to be using in calculations. So these are your paper one equations. All of these could come up. Some of them are potential to come up in sort of forces as well in your paper two. So it's like number one and 10 and 11 could come up in the magnetism stuff in paper two as well, but there will be a separate sort of list for those. You will be given all of the paper two equations as well. So just try to avoid them because obviously the wave equation is not going to come up in paper one at all. Okay. Um, Things to look out for in questions, and something which people rarely do is actually look at the number of marks for a question. It can tell you quite a lot of information. It's not super useful for the written questions, but it will still be useful. So 1 mark questions, if it's a written question, is just looking for a simple statement. What I see too often is people going for sort of the shotgun approach of saying lots and lots and lots, and that doesn't necessarily mean that you actually have to write a lot, right? If it's a 1 mark question, you just need a small amount written. It's more or less just to state that question or write down the definition of whatever. Okay. Um, you can write more if you're a little bit concerned that you haven't written the correct thing, but you run the risk of contradicting yourself. And if that happens and you said one thing and its opposite, you will not get marks. Okay. So just bear that in mind. 3 mark questions obviously mean that you're going to have to write a little bit more. Normally, those are explain or describe questions, but you need to check the command word just to see what sort of answer and what sort of question it's wanting you to put forward. Okay. Um, your what was I going to say? Your answers can always be in bullet points as well, right? There are some of those revision questions that you might have seen that say write you will be assessed on your good English grammar and blah 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 blah. That's not a thing anymore. They as long as you're getting the useful information down and the correct information down, that's what they're looking for. So it does help with structure to write in bullet points, and it can help you see how much you've written and see whether you might have to write a bit more or a little bit less, if at all. Um, and so you can sort of keep that in mind. Okay, where it is really useful though for looking at the number of marks is where you've got calculation questions. So calculation questions will normally start off at the lower end at 3 marks, and what that means is you have one equation. Normally what that means as well is that you don't actually have to convert anything, but there are still some exceptions to that rule. Okay, some things you will have to convert, so just keep an eye out on it. If you've got a 4 mark question, what that will mean is you need one equation, but there's going to be one of these extra things to do as well. So either you might have to convert something, one of the units, or you might need to give your answer to a certain number of significant figures or decimal places, or even give the unit as your answer as well. So you'd need to read the question for that and figure out what exactly you're going to need to do. 5 and 6 mark, those could be using 2 marks. 6 markers are almost definitely 2 equation questions, but 5 mark question could be a sort of range of things. You might have to use 2 equations, or it'll be just one single equation, but with a conversion in there and potentially a number of significant figures or decimal places for your answer, um, or a unit or any of that. But in general, your marks will follow that sort of rule. And to figure out those ones which has potentials for different things, so like the 5 mark question, maybe 2 equations or one with extras, what you need to do is read the full question. What too many of you do is just rush through it, start reading, go, okay, I need to do this, and then assume that you know the rest of the question. Don't assume, because you will make mistakes. Read the question fully, especially the last bit, because that's always where they add on those extras that they ask you to do. But make sure you're reading that question properly. Okay, read it a couple of times, especially when you go back to check your answers, to make sure that what you've written down for your answer is actually answering the question which is asked. Okay. Um, one more thing before we go over our one more thing in 2 parts before we go over a couple of exam questions as like sort of examples is your units, right? So in general, for prefixes of your units, the little bits that go in front, like millimeters, kilometers, that sort of thing, um, only mass kilograms is really the thing that has a prefix in it. Okay, so grams is obviously the normal unit, but the kilo, the prefix, is supposed to be there. Everything else, you need to convert that out. So if you see a normal unit with a letter before it, most likely you're going to need to convert them. There are obviously some exceptions, because there's always exceptions to the rule, and I'll refer to these as sort of special units, and they'll be the things that only come up in 1 or 2 equations. Okay, so stuff like gravitational field strength, that comes up in weight, it comes up in GPE. That's sort of about it for paper one though. That unit is always going to be one of 2 things. You'll never have to do anything with that unit though. Okay, specific heat capacity and specific latent heat, as they're given, you never need to worry about the unit. Okay, it'll be joules per kilogram per degree Celsius or joules per kilogram if it's specific latent heat. You won't need to convert those. You need to keep an eye on the other things in that equation though, because chances are you might need to convert one of them, but the specific heat capacity or latent heat itself, you don't need to worry about. Spring constant is another one. It only really comes up in paper one in the elastic potential energy equation, but that's always going to be the newtons per meter. It's never going to be anything else. You don't need to worry about what that unit is. I put density in in this list as well, because when you're given density, you won't need to convert the unit. But what you would need to do is have a look at the unit to figure out what unit the other things should be in. So there's 2 options for density mostly. It's kilograms per meters cubed or grams per centimeters cubed. You won't need to change between them, but what that means is you need to look at it and see if your mass that you're using in your equation should be in kilograms or grams, and your volume, whether that should be in meters cubed or centimeters cubed. That's what you need to use it for. Okay, but as it's given, you won't need to worry about it. Okay. Um, when you're using these equations as well, when you're looking at them, you will really want to keep an eye on what your answer should be given in as well. If it's given in meters, fantastic, work it out using that equation, you're done. But if it's asking for it in centimeters, you may need to convert your final answer, and that might be one of these extra marks for that calculation question. Okay, so keep an eye on that unit for your actual answer at the end. One last thing before a couple of practice questions, right? On the left is the most important thing. Whenever you are converting, it is almost always a factor of 1,000 that you need to multiply or divide by. Okay, what I see too often is people not being sure, and so multiplying or dividing by 10 or 100. You're almost always going to get that wrong if you use those numbers. If you use 10 or something like that, you're going to get it wrong. 100 is the only exception, and that's only for centimeters to meters. Okay, so meters have 100 centimeters in. Every single one of these other ones is 1,000. Okay, so you need to be multiplying or dividing by 1,000. If you're not sure and you can't remember, just pick one, multiply or divide, and then do 1,000 and call it there. Yeah, what you'll see most of the time, and what I'll point out in one of the questions in a second, is that if you've tried to convert but you got it wrong and you're still carrying on through, you can still get almost all the marks for that question. So it's always worth it to have a go, because you can still pick up marks. What I've got on that table are the um, most common prefixes that you will see. We've got the base unit in the middle, so that would be something like meters or amps or kilograms, whatever it is. Well, not kilograms, that's the wrong one, but you get the idea. It's going to be the base unit of just that thing that we are measuring. The letters before, though, it could be kilo, could be mega, could be giga. Those all mean a factor of 1,000 times bigger. So kilo is 1,000 times bigger. Mega is 1,000 times bigger than a kilo. So that means it's 1,000, in other words, a million times bigger than the base unit. And a giga is 1,000, which is a billion times bigger. Okay, but still to go between them, you are always multiplying or dividing by 1,000. Okay, for your smaller units, you've got milli, so going from a meter to a millimeter, for example. After that, you've got micro, which is 1,000 times smaller than milli, and then 1,000 times smaller than that is nano. Okay, you do have even smaller than that, so something like pico, but you never see that. You also have 1,000 times bigger than giga at like tera. Rarely see that one as well, though. At GCSE, it's mainly these ones. Okay, so if in doubt, multiply or divide by 1,000 because that's most likely what you're going to have to do if you have one of those letters in front of your unit. Okay, remember that if we've got a smaller prefix, so for example, if I've got a certain number of millimeters and I'm trying to see what that is in normal meters, I've got a lot of small things. So my number in terms of meters is going to be a little bit less. I have 1,000 millimeters in 1 meter. Okay. So if I'm going from a smaller prefix to a bigger one, what I need to do is actually divide. I think I got the wrong way around on this slide. But for the bigger prefix, so if I've got a 1 kilometer, if I'm going from the big prefix to the smaller one of a normal meter, what I need to do is multiply. I've definitely got it wrong for this slide because it's the opposite way around. But you're looking at this table, you can convert them for yourself. Okay, the arrows should be the right sort of way around. It's just the two sentences at the top, ignore those. But if we're using those in equations, right, and we're using what I've just been talking about, I've got two questions, calculation ones. The first thing I'm going to be doing for this one, the question is, in one position, the extension of a spring is 8 centimeters, elastic potential energy is 4 joules, calculate the spring constant, use the equation sheet. First thing I would do is look at the number of marks. It's 4 marks. So that tells me I'm going to have to use one equation. There's probably one extra thing I would need to do though. So now I need to look out for what is that extra thing. My elastic potential energy in the second line is given as 4 joules. Joules is the correct unit. I don't need to worry about that at all. But then the extension of the spring, which is a length, is in centimeters. That's an issue. So that's going to be my extra thing. I know that meters is what I should use. This was that exception. And this was where it's 100 instead of 1,000. So my centimeters, they're smaller than a meter. So I'm going to need to divide. And that means that I'm going to take that 8, I'm going to divide by 100. My answer will be 0.08 meters. Okay, and I'd show that working in the lines below in that actual question where I've got the space for it. Okay, you want to show all of your working out. If you've made a mistake somewhere, but you still show your working out, you can still get effectively in a lot of questions all but 1 mark. So you could get 3 marks for this one. I'll show you the mark scheme in a little bit as well. But always show you're working out because then that way it means that you can check your answers and you can see exactly what you did and pick up anything that you went wrong. And it means that if you do make a mistake, but you do everything else right, you can still get marks instead of just getting the wrong answer and that's it, and getting the answer completely 0 marked. Okay, so I've got that conversion. I'm going to need to use that number in meters, the 0.08, in my actual equation. Next thing I need to do though is figure out what equation am I actually using. So what I want to do is look at my variables that I'm given in the question. I've got extension, I've got elastic potential energy, and I've got spring constant. In that list of paper 1 equations, there is only one equation with those in. Elastic potential energy is one which there is literally only one equation though. So that's the one that I'm going to have to use. So I'm going to write that one down. It's elastic potential energy is half times K times E squared. And if you're ever unsure what the K and the E are, on your sheet, you will have it as the word equation as well. And they give it in terms of the exact same order of those things. So I'll know that K is the middle thing. That's said as the spring constant. So K is the spring constant. E is extension. It's in there as well. I just need to remember that it's squared. Okay. So I'm told to calculate the spring constant, that's K. I need to rearrange for it. At the moment, I'm multiplying by a half, and I'm multiplying by the extension squared. So remember to correctly rearrange for it, I need to divide by those two things. I do the opposite. At the moment, I'm multiplying. Opposite of multiplying is dividing, and I do that to both sides. So that means K will be on its own. If I'm doing it to both sides, I'm doing elastic potential energy divided by a half and by E squared as well. So both of those are going to end up on the bottom of the equation. Okay, that's the correct equation. I've rearranged it properly. I've converted the number. My last step really is just going to be putting those numbers in, substituting in. I just need to remember to use my converted one of 0.08. Okay, so if I put those numbers in, elastic potential energy was 4 joules. I've got a half, that's just a number that stays as it is. Then I've got my extension. I'm going to use the 0.08 meters though, and I need to remember that it's squared. And if I put that into my calculator, it gives me 1,250. So that is my final answer. Checking the mark scheme. First off, first mark is that conversion. The second and third marks are correctly substituting in and correctly rearranging. So I've got a half written down 1/2. That's the same as 0.5. It doesn't matter which one you write, it's the same thing. But I've done both of those. I've done them in a different order. Doesn't matter though. Okay, I've still done them correctly, so I'd still get those marks. And the bottom one is my final answer. I've obviously got that correct as well. So there we go, 4 full marks for that question. What you'll see in italics below the second, third, and fourth one though, is it says allow a correct substitution using an incorrectly or not converted value of E. So even if you're not sure about the conversion, if you've pointed out that you need to convert and you've guessed at what you need to do, you might be right and you might get the final answer right and get all 4 marks. If you're wrong, there is no negatives to that. You can still get the other 3 marks. Okay, so if you think you might have to do something and you're confident that you might have to do it even if you're not 100% sure about what you actually would need to do. Okay, have a guess. You should always try these things and always guess because you can always get marks for it if you're right. It's very, very rare that you lose marks for actually trying something. Okay, basically doesn't exist. But this is our first question. Okay, I've got another one to go through, which is a similar question, but slightly different. That last one was on energy. This one's on electricity. We're told town of Hornsdale in Australia has electricity supplied by a huge battery. On one day, it transfers 3.24 times 10 to the power of 11 joules to the town. Potential difference of the town supply is 230 volts. Calculate the charge flow, use the equation sheet. And the very last thing it tells you, and this is why you want to be reading the question properly, is give your answer to 3 significant figures. So looking at the number of marks again, it's 4. That means 1 equation and 1 extra. That means that this is my extra, right? I still would want to check my other units and make sure that they're not just trying to catch me out or anything, but my other units are in volts, which is the right thing, and it's in joules, which is the right thing. So I don't actually need to do anything else. So with that 3 significant figures, I just need to wait until the end to make sure I do that then. So this first thing that I need to do is figure out which equation I need to use, right? So I'm given energy, I'm given potential difference, or voltage is the same other word for that, remember, and I'm asked to calculate charge. So there is only one equation with those 3 things in. It's energy is charge multiplied by potential difference or voltage. So I'm going to write that down. The question tells me to calculate the charge, and my equation, again, it's in the same order as it's written in the symbol one. Q is charge, so I need to rearrange for Q. At the moment, it's multiplied by V, so I'm going to do the opposite to both sides. I'm going to divide both sides by V. That means I get Q, that's equal to E divided by V. All I need to do now is put my numbers in. Okay, like we said before, we don't need to convert these ones, we just need to substitute them in. The power of 10 you can put in your calculator straight away. You don't need to convert it into like a full number. You can leave it in standard form and put that in your calculator straight as it is. At the bottom of your calculator, all of you should have scientific calculators at this point. If you don't, then you've got things to worry about. But the bottom of your calculator, you should see a button that says times 10 to the power of X. That's what you use to put these numbers straight in. So if I was going to put this on my calculator to calculate it, and you can try this now if you haven't used that button regularly before, I would write 3.24. I'd then press that button of times 10 to the power of X. And then all I need to do is write in the power of 10 as it is without pressing anything else. So I press 3.24, the times 10 to the power of x button, and then straight away press 1 for 11. Right? I don't need to press the power button that's up the top near all the little arrow bits as well. Okay, it's included in that other one. You can type that in using those instructions and press equals and see that it actually shows you the correct number as well. That's how you can do that. And what that avoids is you doing the wrong number of zeros after it, either first off, or copying it into calculator with the wrong number of zeros, or like writing down anything with the wrong number of zeros, which is very likely if you've got 10 to the power of 11, that's going to actually be 9 zeros, right? So what we need to do is put those numbers in. The 230 just stays as 230, obviously, and your calculator will show that number, right? 1,408,695,652. This is our answer, but we need to remember that last little extra we needed to do. We need 3 significant figures. Okay. Now, the way that I would need to do this, and just double check that you know how to do this, we need 3 significant figures. So I go from left to right, find my first non-zero number from the left. And luckily for us, it starts on a 1. So that is my first number. Okay. I need to go to my fourth number, the one after my third significant figure. So I've got 1, 4, 0, 8. 8 is my fourth one, and that tells me if I round the third one up or down. So because it's an 8, that's a 5 or above. So that tells me that I need to round that third number up. So instead of me writing for my rounded significant figure answer 140, I'm going to write 141. Okay. The final thing I need to do, and this is something that some people do forget at the very last hurdle, is that I do still need to write that 141, but then after that, every other number in my answer until I get to my decimal place, I need to write as a 0. So I'd need to write 141 0 0 0 0 0 0 0, 7 zeros. What might be useful if you've got a big number like this and you actually have a question that does this is put the little commas for the threes, because then that tells me I've got 3 groups of 3 and 1 extra in my calculator number. Now, when I've done it to 3 significant figures, I've got 3 groups of 3 and 1 extra. I've got 10 digits. I know I haven't added or forgotten a 0, so my number is still the correct one. Okay, that's my number to 3 significant figures. So that's going to be my final answer. And the mark scheme says that would be 4 marks, right? Again, we got the numbers converted if they need to be. In this case, they don't, but they're substituted in properly. It's rearranged properly. This time I've got my answer from the calculator, but then I've done the extra, right? I've put it to 3 significant figures. So these are some things that obviously these are paper 1 practice questions, but this could still be applied to paper 2. I'll probably be doing one of these videos for paper 2 as well, so I'll maybe show some examples of that as well and sort of re-go over this at that point. But this is something that everybody should try to keep in mind. If you're not 100% sure on these, where are they? On the unit conversions, so your prefixes, then it's something that you need to look at a little bit before these exams, okay? But your conversions, that table, the arrows and showing you what to do, that's the correct conversion, okay? Ignore those 2 things up top. Ignore these bits, they're wrong. So that's my bad. But you got that table. These are your prefixes that are the most common ones. That's the name. This is the thing you need to look out for, okay? One last thing, I don't know if I actually said it. There are 2 M's for your prefixes, milli and mega. The way I remember which one's which, mega is a capital, that's a big M, and a big number that starts with M is million. Okay, so if you see a big M, that's a big number, that's a million of the smaller things. Milli is a little m, and milli is a little number. So that's the way I actually remember it. Okay, everything else is fairly straightforward. Micro is the only weird one, but then it stands out because it's the only weird one. So there you go. Okay. I hope your exam goes well. Let me know how it goes, and I will do another one of these recording advice, whatever you want to call them, for paper 2. So good luck.